back to you guys, but I do want to cover a couple of key points. Yeah, so here we are in the day meetup. Thanks everybody for attending. As you know, the Philadelphia user group, we just had our last month where we relaunched the MongoDB user community in Philadelphia. Very well attended event last month, and one of the things that we learned from the previous event was that we've got folks with an interest to have us travel. So not necessarily staying in one location. So this kind of represents our first foray in venturing out. I really can't thank Chris and his team enough for allowing us to come here and present from Walnut St Labs. So that's good stuff. One of the other pieces of feedback that we got was that the content, while it was good last month, we might want to also address the needs of a younger audience in terms of their exposure to MongoDB. So while this is going to present some topics around containerization, the next event, which will be a stutter event, it won't be a full month, it'll be 2 weeks. In 2 weeks we're going to have another event. That one's going to be back in Center City, Philadelphia, and we're going to talk about the basics of MongoDB and how you get started. We'll show downloading the Mongo binaries, launching Mongo, jumping into the shell, and kind of looking at what the basic CRUD operations look like from the command line. And then still working on the content, but that'll be the gist of the next session. And then in 1 month again, we're going to move once more. I don't have the venue picked out just yet, but I'll keep you guys up to date on the meetup. I did want to cover a quick announcement about MongoDB World, which is happening June 28th and 29th in Manhattan. I don't know if you've heard about this event, but it's a pretty phenomenal event. There's going to be some amazing speakers. The keynote speaker is Adam Savage from Mythbusters, so that should be really cool. And then we've also got a coupon for you guys. If you're really interested in going, we have the ability to give you a coupon code that's and you can get 25% off of admission, which is pretty phenomenal. So that brings us to the mainstay of tonight's presentation, and I'm really going to turn it over to Brian and Dan, who are going to talk about containerizing MongoDB with Kubernetes. So we'll kind of pause for a moment while we switch gears.
Hey, Mike.
Yeah.
You said you were going to try to address like newer people that are newer to MongoDB and so forth. I've had to write and present off my laptop a number of we'll call them very short webinars to augment some of the things that both the Java and the admin. If you want, I can send the links in case anybody wanted to kind of look at them ahead of time.
Send the links, but if you're willing to cover some of that, I welcome your participation.
I don't mind doing it. It'd be more about like when is it going to happen and if I can be here.
We'll chat offline. Okay. Thanks, I appreciate that.
No problem.
So let's welcome Brian and Dan. Thank you. Just a quick poll. While Brian's setting up, how many people have heard of Kubernetes? Docker? How many are you using Docker? How many are you using Kubernetes? Some Docker people? Some Docker. No one using Kubernetes? Yeah. Cool. I don't know what to say.
Yeah. So thanks everybody for attending. Dan and I are going to be talking about how MongoDB can be containerized and used with Kubernetes. By way of introduction, I'll let you introduce yourself.
So earlier, my name is Dan Worth. I'm a software engineer, director of engineering at TV. We're an online sports-first streaming platform. Right now, it's primarily soccer and DJ work on the internet.
And my name is Brian McNamara. Most of my experience has been in the ops world. So I currently work as an ops engineer On the side, I do consulting work as cloudy ops, like learning about new things, including Corny's 80s movies. So if any of you share that, let me know. Sure thing.
You're not alone.
No. So in terms of an agenda, what we're going to be talking about, we'll be addressing the fundamentals of Kubernetes, the fundamentals of MongoDB high availability, and the challenges of running stateful services in general on Kubernetes. So keep that in mind.
So some background around Kubernetes. Kubernetes was released in 2014, and it's based off of a system called Borg, which is how Google deploys all their stuff internally. And it's a container, so a Docker container for any container really, scheduler. And what that means is you tell it you want X number of containers to run, and it will schedule them across a fleet of machines. So Kubernetes is open source, primarily developed by Google, but it's a very large community, and some other larger companies are helping out. Red Hat is one, DAS is another, and there's a bunch of other. Yeah, and it's a very active, helpful community. So if you're interested, join the Slack channel or the groups. It's not specific to any one platform. Google has a thing called Google Containerizing, which is Kubernetes under the covers, which is what we use and what pretty much we're going to be talking about Kubernetes from a user perspective today, not as an ops, and setting up and managing a cluster. But you can run on AWS, you can run on bare metal, Azure. It's a self-healing system, so when things go down, it brings them back up. There's concepts of service discovery and load balancing, some secrets management and configuration management objects. But some of the core topics that we'll be discussing and we've leveraged in deploying Mongo to Kubernetes are pods, replication controllers, and services. So to dive into some of these concepts a little deeper, pods are your lowest level. So a pod is a set of containers. So it's the lowest level schedulable thing in Kubernetes. And you can have more than one pod. And pods allow you to define the environment. So you basically will tell Kubernetes, I want you to run this container. I want this container to have 3 gigs of RAM, 1 CPU, these environment variables set. I want these disks mounted to it, and then you hand that off to Kubernetes, and Kubernetes will run that. And here's an example snippet of a pod container declaration. So what this is we're going to have a Redis container. It's going to be based off of the Redis image, which will be pulled from since there's no path information here, it is pulled directly from the public Docker Hub image, or Docker Hub repository. Excuse me. And the Google Cloud Platform has a private registry that you can use, and Kubernetes on GKE knows about that automatically. All authentication just happens, which is nice. You can define the ports, and here's some resource limits, so 1 CPU. So before we move on, questions? Any questions about this? Does it make sense? Keep going.
I'm one of the least technical people in the room, but I just set up a whole bunch of stuff on Rackspace and load balancing, and they have these things called stacks that kind of make it easy, but everything got fucked up anyway. And is this making it all easier?
Yeah, this actually makes it extreme. Leveraging something like GKE, so the hosted Kubernetes basically, on the Google Cloud, you define what application you want in terms of Redis, or you have some Docker container for your app and it needs to access some database. Mm-hmm. You group all those things up in a config, you hand those to Kubernetes, and make sure that they all run and they can all communicate with each other, and you're in good shape.
But you have to make sure you set this up right the first time, or else you're going to have the same mess that he's
with
having,
the
right?
configuration.
Right.
Yeah, so you define the config. As long as you have the configuration set up correctly and you hand it off, yeah, you're in pretty good shape.
Well, and a quick survey question. For those of you who are using Docker, were you using VMs prior and moved to Docker? Did you start with Docker? I'm assuming you went from VMs to Docker or physical hardware. What are some of the challenges that you saw in the move? Like people, all across the internet, Docker is presented as this wonderful thing. And I'll say by and large it is, but it's not without its challenges. So, the question of would my stack have gotten as screwed up if I was using Kubernetes, kind of a loaded question. There are definitely things to consider, and it's not to say that things are perfect, but it solves from, as an ops person, it's nice to have a lot of the application ops taken care of. You don't have to, if your configs are right and your application code is correct, you can say to Kubernetes, this is the state that I want, make it happen. You don't have to declare, I need a VM, I need this amount of disk, I need to worry about firewalls, I need to worry about, a lot of that management.
It's declarative by default.
It's declarative, yes.
Exactly. And that's, I think, like,
yes. Yes.
One of the early challenges with Docker was the networking.
Yes.
They've gotten much better, but I know Kubernetes handles that to a certain degree.
Mm-hmm. Yeah, GK specifically makes things really nice. If you look at Kubernetes operations, there are certainly a lot of things to consider. Networking is one, and I know Docker's taken one stance versus Kubernetes. Like, one of the nice things about pods, like if you contrast that with like just running regular containers, is every pod gets its own IP address. That makes things nicer. You don't have to worry about bridge networking and all that fun stuff, or worry about overlays as much.
I'm sorry, one more question. In Kubernetes, my understanding is that even though you can do it, like you say, every pod gets its own IP and so forth, whereas Docker seems to be headed more towards let's launch a VM, let's launch like Core OS or Rancher, and then let's put VMs on the VM.
Uh-oh. Still working.
It'll work.
Accelerometer, what is the other?
We'll keep that there.
I probably have to ask any more questions.
No, that's okay.
So you don't need to answer it now, but when you kind of get to that area, can you address that?
The networking aspects?
Yeah, I like the idea of VMs on VMs because your security is theoretically better.
Yes.
Because they're talking to each other on that VM, and then you only have to open up one port out for whatever you're trying to expose.
Okay.
So now I have a much simpler question
Sure.
to ask, because I just need some context.
Sure.
I just need you to set the stage, because I know Docker is for containerizing applications. I have a vague idea what that means. I don't know how that relates to Kubernetes. And much to my surprise, the Kubernetes web page is talking about deploying your containers in Kubernetes. So there's some sort of hierarchy going on. Can you just kind of give me the view from 10,000 feet?
Sure. I just want to jump in too. With the great thing about Docker, it's easy to get started. Go ahead. It's easy to get started if there are VMs that you can spin up and run containers. Great to get started, great to experiment. The downside is if you're running production workloads, there are a lot of other things to consider. Things like scheduling, like what happens if that one container goes down? What about logging? What about mutation? All these things that you need to address. Kubernetes is really opinionated, and it's pretty narrowly focused. It's a container scheduler. So the same container images that you work with on your laptop, on a VM, whatever, you can hand over and say run on Kubernetes, and where that Kubernetes cluster can live in AWS, Rackspace, wherever. It really doesn't matter.
For scaling up multiple instances of
Scaling up, but even beyond that, managing the things that are important, like, Dan will talk about this in a little bit, but things like networking, things like availability. Kubernetes does a really good job at scheduling things, so you as a developer don't have to worry about it as much. Like if you use the right primitives, you can say, here's a container, run it, and ensure that it keeps running. That's really all it is. So you can use that same Docker image and just run it someplace else inside your laptop.
So you say you have 3 servers, and you run the container, one container on each server, are you leveraging all the resources of those three servers? How do you know that? And how can you, maybe redefine how you schedule or run your containers on those three servers? Kubernetes really helps with that. So say this one thing needs 3 gigs, and I have 10, and something else needs 5. And Kubernetes will figure out, oh, there's room here, I can move here, or I can move it around. So I can really leverage the resources that I'm paying for.
It doesn't really like resource allocation and scheduling. Scheduling to me means time slicing, and that's an outdated use.
A little bit of both. So like in that instance, it's more concerned about resource allocation, making sure that the resources that you have are being used optimally. But also, you can also declare what you want, what services you want running as well. So it'll look and make sure that your container can be scheduled based on resources available, but it'll also look and make sure, if you declare that I want 10 things running,
how many
make sure I have 10. Yeah. And if there's 11, bring one of them down.
Got it.
So it's an orchestration. You do the orchestration things. I get confused with one question: Docker, Chef, Puppet, now in a Kubernetes. I'm getting confused. Why so many things? And when I go Google it, YouTube it, everybody talks about, hey, it's going to orchestrate.
Sure.
In a cloud, it will create something in the cloud. So then I asked one of the ops guy, because I'm in development side, so I don't know what is going on there. So he said the Chef is the better, the tool than Docker and Puppet. Then he talked about a Go language in Kubernetes. That's what he's doing it. I said, okay, I need one more beer. Maybe next week we'll talk about it. So
yeah, there's definitely a lot going on, and it's interesting how there's more and more overlapping in tooling. So it makes it difficult to discern when to use one thing versus another. If you look at tools like Chef, Puppet, Ansible, Salt, they really came about to mutate servers and ensure, like, you have a desired state. I want my machine to have this package, this user, whatever. Here, you can be declarative in what you want your VM to look like. Things like Docker change that paradigm a little bit, in that you just wrap your application. As an application developer, you don't necessarily care what packages are installed, you don't care what versions, you don't care what local users, you don't care what auth means, at least not at the host level. You want your app to run somewhere. So the idea behind Docker, some of the advantages of using containers, you have less resources consumed by a container, but you also wrap it up, so you don't have dependency hell. Like, how many of you guys have more than one app running on a host? Have you ever had to support that? Or one code base with multiple packages, and you're like, oh, crap. This version conflicts with this. Well, the idea behind containers is you don't care. The underlying OS can run whatever, can have whatever package versions, that's fine. With your container, you have essentially a hermetically sealed app saying, boom, here. I'm running Python 2.7. You can run 3.4 here. It doesn't matter. And they can run on the same host.
And from a development perspective, I want to be able to see exactly what's running in production, but an ops or an admin is not going to give me access to production, right? But what I can do is I can take and say, here's the container, pull it down, shell into it, and you look at this is the exact code, the exact dependencies. Every single thing that is in production is now on my machine, and I can poke around and look at it. So from a development perspective, containers are fantastic for that. From an ops perspective, is saying, this was checked off by QA. I want to take that exact thing, move it to production. And you just take that container, move it over to production, and you're in good shape.
Good answer.
Isn't another way to look at it, though, too, is that, like, when you, like everything else in the computer biz, you're building on the shoulders of what came before. So that, like when you talk about Chef and Puppet, it was great for, it's not that it's not bad. It's not that it's bad now, but it was great to handle the situation then. It beat all the heck what you would do before.
Yes.
Then containers came along, and they're more lightweight, and then you're leveraging the underlying OS scheduler, which is way smarter than anything we could write, as far as making sure that you're using the resources that you want to use.
Well, and the other important thing to note is that they're not diametrically opposed. You can run Ansible, Chef, Puppet, whatever, to configure your underlying host. Like, you should be using config management if you're managing physical hardware, if you're running VMs. I think it's a very good idea to have config management, ensure consistent state. But you can still run your containers on top of. Certainly services like Kubernetes, Google Container Engine, in Amazon there's the Elastic Container Service. They abstract, or they really make it so you don't have to worry about the underlying OS or whatever, but somebody still has to worry about that. Just a question of whether they're an Amazon employee, whether it's your own ops team. So you should be using config management, but you can do both. You can use config management with containers.
Move on.
Yeah.
Cool. I think we're good. We're on the
Good.
next slide. So the next level of abstraction is a thing called replication controllers. So replication controllers are actually really neat. It's like a very nice part of the Kubernetes ecosystem. And what it does is, this is the thing that says, all right, so we have these pods, right? And this pod is deployed to Kubernetes and it's running. But if that pod dies, it's done, right? It's done. And there's only one of them, and whatever. So you wrap a pod in a replication controller. And a replication controller says, I want this many pods running at any given time. So if one dies, I need you to bring another one up. Or if for whatever reason we have more than we're supposed to, I need you to scale that back down. And it also allows you to name this group of pods, which then will leverage a load balancer. I believe it's an L3 load balancer. So meaning that you can have 10 pods and a single entry point to those 10 pods, and then Kubernetes will load balance across those 10 pods. So you don't have to care about this. I need to, figure out like what the pod IPs are and stick Nginx in front of it. Kubernetes will handle all of that for you. And that's, for the most part, that's what we use replication controls for. Say I want this number of pods up and running at all times, and for load balancing. So then the final piece that we use to leverage our Mongo deployment to Kubernetes are services. So services are how we get our real IP address to that replication controller. So I want an IP address that is not going to change between restarts of pods or creating new replication controllers. So one of the topics that you'll kind of notice is all of these concepts are decoupled from each other. So you can create a pod, or you can create a service without a replication controller. And what that means is I've created this service. It's going to look for things with these selector labels. It's going to get an IP address. And then once a replication controller, once something that meets the criteria of this service, then traffic will be routed to that specific group for replication controller pods. So we can, and this is kind of how we can do port redirecting, I guess. I don't know if that's the right term for it. So this service says, I want Redis on 6397, which is the default Redis port. And then the target port for the replication controller happens to be the same thing. But this could be 6380, and this is 6397. And then the service will actually do the port rerouting. Cool. Thanks.
Questions there?
One other thing with services, you also get if you have SkyDNS deployed, which is by default at this point in GKE, you will get a DNS name that will resolve to this IP within the cluster. So you can do like myservice.mynamespace.service.whatever, which is handy. So this is kind of a diagram I stole from the Kubernetes site, but it kind of gives you a sense of the service IP, and then kubeproxy is a tool that runs within each Kubernetes node And then that's how the routing happens to each one of your pods. So these are, the same pod running, as a replication controller, and then so your application kind of. And Brian's going to go into some MongoDB high availability stuff.
Cool. So show of hands, and I know people were pretty much talking throughout. How many of you guys are using Mongo for experimentation? Okay. If you're using Mongo in production, this may be a review, but I promise you it makes sense in a little bit. So MongoDB is a document-oriented database. There are two ways to scale things in Mongo. You typically either want to scale reads or writes. When you talk about scaling reads, you use a concept called a replication controller. If you want to scale writes, you use shards, where essentially keys are allocated across a cluster, and then based on the shard key, writes occur. Clients, so MongoDB clients have the ability to specify their read preference. So if you care about latest, greatest data, if you want to read the latest write, you can read from your primary member of a replica set. You can ultimately specify primary preferred. So if for some reason the primary can't accept the read, you can read from the secondary. If you don't care about latest, greatest data, you can specify that you prefer reading from a secondary you can specify secondary or secondary preferred. You can also use nearest to try and determine where the nearest MongoDB server is. Ultimately, you can also use something called a tag set. Have you guys worked with tag sets much? If you haven't, they're actually pretty cool. You can actually define user-specified tags in your replica set configuration, so you can have isolation at, let's say, a rack layer or a data center layer, and have your client specify, like, I want to read from east rack 2. So it's a nice way to get locality.
Even on a larger concept, if you, let's say you're a really large enterprise and you have compliance restrictions where you have data residency restrictions, you can craft a tag set where it's geo-aware and your German data stays in your German data center.
Yep, that's an excellent point.
You can also use them for business reasons. If you have a lot of data and you just don't want the data divided up between your shards, you may notice that 98% of your reads are coming from the last month. So you put that on a slightly stronger machine, you keep that small bit of data there, and then in essence you're archiving everything else. So it's still readable, but you're getting better traffic control.
So for the purpose of this conversation, we're going to be talking about using replica sets to scale reads. So we're not going to talk about sharding. That's a little bit more complicated. This is essentially what a 3-member replica set looks like from a client standpoint, where reads and writes by default are occurring against the primary. Replication then occurs where the secondary members read from the oplog of the primary to keep themselves up to date. Again, by default, if you don't specify a read preference on your client, by default it will hit the primary, but it doesn't have to. You can change that. Also under the covers, there's a heartbeat that is occurring between all the members of the replica set to determine health. And we'll talk about why this is important in just a second. If a member becomes unavailable, so in this example we'll use a primary node that's marked unhealthy, the secondary members will elect a new primary. The way that, essentially in order to elect a new primary, you need n divided by 2 plus 1 members healthy. So if you have a 3-member replica set, you need two nodes available. If you're down to 2 and you lose 1, you're out of luck. At least from and correct me if I'm wrong, you're okay from a reading standpoint, but writes can't occur.
Correct.
Yep.
And the way to think about it is, of the remaining, so a majority of the remaining nodes.
Yep. So in this instance, we have 2 members that are left. One of them can be elected primary. The great thing from an operations standpoint is no operator intervention is required. So, yay. That's a really good thing. So some of this, I'm not sure how clear this is for other people, but this is a printout of what configuration looks like. I've highlighted a couple things, but one, you can look at, this is essentially a list of members. You have the host definition, including the IP or host name and the port number. You can also specify some interesting characteristics of your Replica Set members. Now, by default, all members can vote, all members are visible. That's great. Depending on your business needs, you may want to change things up a little bit. If if you have one or two servers that have beefier hardware, you may want to increase their priority, so their likelihood of being elected primary to handle those rights. If you have an even number of servers, you can change the number of votes that server gets. So when a new if there is an election event, you can keep one of them out if you want. You can also specify whether you want your Replica Set member hidden or not. Why the heck would you want to hide a Replica Set member? If you need to archive things, you need a backup, reports, it's a great way to use fresh live data without hitting your production cluster, or without hitting the other members of your cluster.
Oh, it's still being kept current, but no one's
still being kept current, but no one can use it. So I highlighted host for a reason. We'll come back to that in a little bit. So let's talk about running. Let's shift gears a little bit. Let's talk about the challenges of running stateful services on Kubernetes. So, as Dan mentioned, Kubernetes is really good at running and rescheduling containers using really basic concepts like pods, replication controllers, and services. If you haven't heard of this gentleman, Kelsey Hightower, has anybody heard of Kelsey Hightower? He actually presented at Philly ETE last year. He's now a Google developer advocate. He was at CoreOS for a while. He's a great speaker. He did a great presentation last year at Philly ETE on using Kubernetes, and that was a real eye-opening experience for me and for him as well.
He was at ETE this year also.
He was? I didn't make him. So stateless services are really targeted very, very well for Kubernetes. You can use replication controllers if something dies, bring it back up, everything as well. But sometimes we need things to maintain state. And initially, when we started looking at using Kubernetes for Mongo, there wasn't a lot of great information out there. So in general, let's talk about the challenge, specifically, let's talk about the challenges of running Mongo on Kubernetes. So replication controllers are good at ensuring a certain number of pods are scheduled, but replication controllers don't guarantee a consistent endpoint. So yes, a container can be rescheduled, but remember with pods, you get a new IP every time. So that's not great when it comes to configuring MongoDB Replica Set, because you need those well-defined endpoints. So if we harken back a couple slides, this is a sample of what a replication or Replica Set configuration looks like. You need that fixed IP or host name. What you don't want to do is update things manually. That defeats the point. And this is my little, I won't say dig, but updating Replica Set configs by hand, it feels dirty and you're a bad person if you want to do that. So don't do it. There are things that exist that allow you not to have to worry about that. Also, Mongo data should persist. So, yes, you can schedule a new pod to come up. If you don't have any data there, Mongo's going to do a full sync. So that pod is not going to be able to serve traffic while that sync's occurring. There are things that you can do. So Kubernetes is great at the scheduling part, not at maintaining data, or not at maintaining state of the app. So I'm a sad fan. The good news is there are things that you can do. We can take advantage of built-in Kubernetes primitives. As Dan mentioned earlier, we can use things like replication controllers and services to give us those well-defined endpoints. We label selectors in your replication controller and service allow you to have that consistent endpoint regardless of the IP of the pod. The one other thing that's really cool too is you can have persistent volumes in Kubernetes as well. So this is across a number of providers. So it's not native just to Google. You can do this in Amazon as well, or at least for cloud providers. You can use Google Container Engine to create Google Compute Engine to create volumes, but then have replication controllers move those volumes around. So if a container goes down, and it'll be rescheduled someplace else, the great thing is the actual data volume can move with. So you don't have to do that full resync.
Right, because that container can be rescheduled on a completely different host.
Yes.
Totally different node, different availability zone.
Yep. So by having that network volume, it'll move with. Now I know there are people who there are different opinions on whether that's a good thing or not, whether you should use network storage, because even though it's a persistent volume, the reality is it's not local storage. Again, this may not be for everybody, but when it comes to running Mongo, my experience in the past has been you want to run local disk as much as possible. The benefit here, though, is that you get the flexibility of the rescheduling.
Does Kubernetes have like a built-in DNS server? Because in essence, that's how I've gotten around it. I don't want IPs; I just want them to reroute to the new IP.
Well, even there, though, for DNS, you still want to define a service endpoint. Mm-hmm. And again, whether you reference it by name or IP doesn't really matter, but it has to be consistent. So in your configs, if you define, like when you're doing your Replica Sets config, just make sure you reference things by that well-known endpoint, whether it's IP or name.
When this is not a Kubernetes question, but I kind of want to know if you can do it under Kubernetes. What I do for when I want to have the data easily moved or to a new place is I keep the data local, but I do LVM backups to a mount point. So I'm, in a sense, trying to get them, slice and dice it a little bit. Could you do something like that, and do you have any opinion on that?
So there are a few ways of approaching that. If you work with a cloud provider, so we're using built-in Google volumes. So we're just taking snapshots.
Same thing with Amazon
Yep.
and all that. You can tell I've had to build a lot of these things from scratch.
Yep. So yeah.
You can share volumes across containers, across pods. So if you mount one volume that you're going to use to kind of redistribute to, say, another application pod, you back up from one, copy it over, and then you go into the other pod, and then it's there. So you can, I don't know if that's what you're getting at.
Yeah, at the end of the day, but you're right. If you're going to put it up on Amazon or something, it's much easier to say, please take a snapshot right now.
Yeah, that's very
The downside there is that that's typically platform specific. So an EBS snapshot that you take is not portable, but like I know people have different opinions about whether or how much you should rely on vendor feature versus not. Like you could do a Mongo dump, right, and do the same thing, but it's going to be slower.
Yeah, well, then
snapshots are really fast.
Then you drink a lot of cups of coffee waiting for the Mongo dump to get done.
Yes. And the nice thing too is that you have your indexes there as well.
Sure.
On the resource. Kubernetes right now does not have scheduled tasks. So there are a number of container schedulers out there. Mesos is one, so you could use things like Marathon and Kronos to actually do scheduled tasks at a recurring interval. Kubernetes isn't there yet, but it's close.
1.3.
But it's close.
Yeah, 1.2 is the current one.
Have you ever used Mesos here?
I have not.
Just curiously, I just went open source like a couple weeks ago.
Yeah, a friend of mine evaluated it while using Kubernetes.
Okay.
That's just the launch. It's a little heavy.
Can I ask a question?
Sure.
On the management of the scheduling, as it's moving data, does this also optimize how you charge from, say, AWS because of the data movement during peak times and other times? Does this help to manage that at all?
Not that I'm aware of. Typically, at least my experience, I have much more experience with AWS than Google, so I'm learning on the Google side. If you keep things local, in the same region, that shouldn't be a concern. It's typically only when you go out of a region where you have to worry more about transfer costs, at least from a monetary standpoint.
Yeah, let's say you had an application that one of your services managed users, and you discovered on the first of every month HR dumped in a gazillion users. So you can just schedule it to, in essence, put 2 of them up there, but that you're only paying for that 1 day's extra time. I don't know if that's what you
We
meant.
have to juggle that because we're using video and music files and saving them and archiving them. So some of them we want to keep local because they're more in demand, and others we have to archive.
Sure.
And that movement, it costs money. So anyway, thank you.
Sure, and I'd actually be really interested in talking about that after.
Okay.
So, yeah, these are all great primitives that we can use within Kubernetes. Within Mongo, we can use the service endpoints that we define in Kubernetes when we create our replica sets. So in that way, we don't have to, if we do have a pod get rescheduled, we don't have to worry about changing the replica set config. We're using that well-defined endpoint. So, do you actually have code examples? So let me know if you guys can't see. This isn't great, but let's see what we can do. Yeah, Zoom is horrible. This is an example of a replication controller code. So, we saw a snippet earlier of a Redis one. Here, we can see what the spec looks like, the image that we're using, the volume mount, the mount path, the actual volume itself within Google, as well as the Docker command used to run or instantiate that container. We also have a count. So replicas is set to 1. With Mongo, I wouldn't recommend going more than 1 because you lose that association. Then, one service to one replication controller, you want to keep that as a 1-to-1. But this is essentially what a
Command plus not work?
I'm sorry.
Command plus.
Yeah, that's
No.
right.
Command control plus.
Yeah, or the command control or command option. Neither one. But I have a link to it later, so we can.
Okay, cool.
We have to make sure we see it. And then on the service side, let's take a look at the source here. So the service is actually pretty straightforward, where we have a selector and then the ports that we want to expose and map. So really all the heavy lifting is being done in the replication. So I'll say parting thoughts. Mongo has good resilience in the face of failure, but make sure that you test your failure scenarios. For those of you who are using Mongo in prod, what things have you tried to work out in advance before moving forward? What do you test?
Opposite problem now.
Right?
Good man.
So first rule of high availability computing is you want to define the failure scenarios that you want to test.
Okay.
I haven't really thought about that, but you can get really surprised.
Yes. Things will fail in interesting ways. So you can try your best, but make sure that if you are planning out your replication set, make sure that you test what things look like when you lose one host. You lose 2 hosts. You lose n plus 2 hosts, and divide by 2 plus 2 hosts. See what happens. The great thing is Mongo is very resilient, but again, make sure you test. Docker is great to work with, but make sure your development workflows, tools, and harnesses are there. I'll say, Dan, if you want to.
Yeah, I mean, so, right, I'm sure everyone's heard of like the microservice movement and Docker and all this stuff is fantastic. And Kubernetes makes it great to deploy it out into the world. The challenge that you run into is how do you replicate what your production environment looks like locally? So I want to bring up the full app. So there's definitely challenges with that, with local development. And if anyone does that and they're happy with how they do it, let's talk, because I hate how we do it and I'm not happy with it. But one tool that helps is Docker Compose, which allows you to kind of define your environment. And if you're using a private container registry like the GCE or the GCR, Google Cloud Registry, authentication is slightly different, so just be aware how there's some docs on their site. So if you're trying to pull Docker images down through the Google Cloud Registry with the straight Docker tool chain, it doesn't work so well because of the authentication. But there are ways around it, and you can handle it, and it's documented really well. But those are just some local development gotchas that you need to do.
My feelings on Kubernetes and Docker, any of those types of ideas, is that it's really easy to set up an environment on your laptop and for a development team and everything else. But when it's time to actually deploy them, it's less than fun at times, because that's when you actually run into some things that you hadn't thought about. And as far as testing, MongoDB is probably the most configurable data source I think I've ever seen. So the advice that it sounds simple, but hardly, I don't think that many people do it as they should. You have to put it under realistic loads of realistic payloads of the document sizes and everything else, and your reads and your writes, and or you're not going to know what's going to happen. I mean, I don't know if you agree or disagree, but
No, I personally agree.
I'm right there with you. I mean,
Absolutely agree, and one way to find even more holes is point your production load at your concept, and it's going to shine a light on how you've laid out your document. One key thing with MongoDB, if you've used it in production, is the key thing is defining. Okay, sure, it's a schema list or a schema on read or whatever you want to call it, but that doesn't alleviate the need to examine how you're laying your document structure out. And one great way to find that you've skipped that step is to point production load at a document store. So I just beg you to spend enough time thinking about how you're going to query your data so that your document, the shapes of your document support the types of queries that you're executing against those loads.
and if a document is going to update a lot versus get put in and only read, update a lot causes a couple problems. There's the overhead, the update, but the people don't necessarily think that this actual document is going to get bigger than it should get.
Remember, we have a 16 megabyte
size.
Unless you want to store
unless you want to use GridFS.
Yeah.
But the other things to consider with Kubernetes too is your CICD workflows, continuous integration, continuous delivery, or deployment. It's easy to get started, but as you mentioned, running it for real with real developer workflows, it's different. It may alter your observability too. Like, how many of you guys have ops team members who will SSH onto a box and tail locks?
No.
Doesn't happen.
No.
It's been known to happen. So what do you do for logging? Things like that. Things that you should be instrumenting for, period, become a necessity when you move from the VM model to the container model.
Do you use like a common place to put your logs and then use like an elk stack? Or that's assuming you don't want to spend the huge amount of money for a more commercial product?
What we do use.
Is that what you use?
Logly.
I've never used that.
There are hosted services like Sumo Logic or Splunk Cloud.
Yeah, and so we just ship all the logs for
Have you used
Your
Brave?
services are configured to ship.
Yeah, so actually, it's a little, I mean, we can talk about this later if anyone's interested, but yeah, we use a sidecar deployment, so we can basically, the app dumps logs, and then another app uses Fluentd to actually pick up those logs, shut them off, and use them.
Okay, thank you.
Another thing to remember, Kubernetes is still relatively young. As Dan mentioned, it was released in the summer of 2014. I think it went 1.0 last summer. But it's maturing very quickly. Google is really in tune and is listening to the community. Like, I was blown away
I was on a call with them today, actually, asking for feedback. They send out surveys all the time, and they actually, they'll jump on Hangouts and really want to understand how you're using things, how you expect to use things, what they're not doing well, what they are doing well, so they're very receptive.
Yeah. And if you use Slack, they do have a community channel, very active, very active, which is nice. In general, I think you need to carefully evaluate whether you want to roll your own or use a hosted service. And this is true of any container management, whether it's Amazon, Google, whether it's Amazon with Elastic Container Service or GCE with a hosted version of Kubernetes. My 2 cents. Any party questions?
Just on that note, have you looked at OpenShift at all?
Have not. So OpenShift is Red Hat's
Their new
platform.
version. Yeah, version 3 was built.
They're in at KubeCon. They were prominently featured. I personally haven't used it, but I mean, have you worked with it all? Or?
Kind of peripherally, but I don't know if they're public offerings at version 3 yet.
Gotcha.
So I was doing some work at Cisco, and we're just starting to use this.
When you post this, is it possible that you could maybe add, it doesn't have to be on a slide, but add a list of some of the better places to, you got it already.
We can do that. So yes. Yeah, and again, if you haven't seen it, this is the Philly ET presentation from last year. Mind blown. It's a good one to watch.
Yeah, any Kelsey Hightower talk is actually really good.
Yeah. Cool. Well, thank you much.
Thank you.
Thank you.
Awesome. So that kind of concludes what we had planned for tonight's Philly Mug. I want to thank you all for coming out, and special thanks to Brian and Dan for putting the presentation together. It's pretty phenomenal stuff. What's everybody think about the presentation?
Good.
That's great. Awesome. So I'm going to leave some cards up here. If you guys have questions about MongoDB or anything related, please feel free to use the contact information. I'm also always on the meetup group and the discussion groups there, so if you want to start a discussion there, by all means. And I guess with that, we'll conclude for tonight.
Is there, I said this last time, but I'll say it again. If there's anybody who wants to learn either